Okay, so if we're looking at how many days do we have to wait from one full moon to the next, the length of time there is going to be the period. There's a couple of different ways that we can do that. We know that the period is going to be 360 divided by this value, or we can look on our calculator and find out the length of time it takes to go from 0.5 up to the next 0.5 and then the third one. So for part B, what we can do is we know that our intercept's at 0.5, so we can do xcal 0.5. So that's our first one, our second one, and our third one is going to be at the point where it starts repeating. So we have a period of 29.5. And this is actually the length of a lunar month. So on part C, we are looking for at least 65%. So that's going to be when f is 0.65. And we need it at least that. So if we've got a decimal, we are going to have to go to when it's slightly more rather than the other way around. So if we substitute that into our equation, we need 0.65 is 0.5 sine 12.2t plus 0.5. On our calculator, we are looking at xcal 0.65. So our first one happens on day 1.4. So in order for it to be more than that, that's going to end up being day 2. So we have t equals 1.4. So we're looking at day 2. And then, so it goes up and then comes back down. And that is at 13.3. So we can't use, or we can use some of the 13th night, but not all of it. So we're going to have to go back to 13. So 13.3. So day 2 to day 13. So our trip can be at most 11 days. Okay, so copy and complete the table and plot the graph for April. One of the convenient things of these calculators is that it remembers as you go from one bit to another. So we can go across to table, we can set up our table. It's going from 0 to 30 and going up in 5s. So if we show our table, then we've got our values that we can just enter in. So we're starting at 0.5, 0.937, 0.924, 0.474, 0.051, 0.090, and 0.552. It's worth noting that this doesn't actually give us our maximums or necessarily all of our points where it's going to cross the middle. So from a practical point of view, you need to make sure that your maximum is plotted right and your minimum is plotted right. So if we draw this and do G-solve maximum, that's going to be y equals 1 at 7.4. So we're looking at about here. And if we look at G-solve minimum, that's going to be at 22.1. So 22 is going to be about there. And if we look at our midpoint, so when it's at 0.5, we've got xcal 0.5. That's going to be at 0, which we know, 14.7. And at 29.5. So plotting this, we've got 0.5, we've got 0.93, which is about there. We've got 0.92, which is there. We've got 0.47, which is there. We've got 0.05. So that's about there. 0.09 is there. And then 0.552 is about there. So bits that we need to be careful with. We need a smooth curve. It's not allowed to be what they refer to as sawtooth, which is basically goes up and down. We've got to make it so that the bits where it's coming to its maximum and its minimum are flat. That'll do. So we've got our maximums in the right place, we've got our minimum in the right place, it's crossing at the midpoint at the right place, and we've got all of the other bits it's after plotted. Okay, so then we're after between what days is the greatest increase? Greatest increase is going to happen at the steepest gradient. Steepest gradient is going to happen either at this point here or at this point here. So that's going to be the change between day 29 and day 30. That it's going to get its steepest increase. So, because the increase is just your rate of change, so if you think about it from a calculus point of view, you want the biggest gradient. So between day 29 and 30. So that would be the 30th of April and the 31st.